Look, sometimes I stream at different times than other times when I stream. It's just how it is. Have I seen the new? Wait, there's a software and game development? What? Hold on. We might have to change our entire. Wow, they finally did what? They finally did it. Let me see who's. Does that mean there's no more ducks while we stream? Wow. That's pretty amazing. Pretty amazing. Except we're not listed there, even though I just changed the stream category. So it's broken. Do people not see the category? It it should. We're not there. Oh, yeah, we are. Okay, here we are. I was blind. It just wasn't standing out in a field with the red fox and the angry fruit salad and the other angry fruit salad. So great. Okay. What is my opinion on algebraic data types? They are basically useless. For regular programming. If you're like theorem proving or whatever, then maybe that's a different thing. But they're basically useless. So I wanted to start out today. We got one more bug filed on the polymorphism stuff, and it caused me to reflect on whether I can simplify some of these things. And the answer may be no right now. Or I already found one thing that makes it slightly simpler, but the history of this compiler has been it's got a lot of features. The features interact in a very complicated way. Initially, when I program them, I can barely do it. And then I figure out how to do it better later. And that results in better results. Sometimes features that you think wouldn't be that bad turn horrible when they combine with other features. So for example, one of the biggest pains in my butt is procedure overloading, just like calling a function that could have multiple definitions. It sounds easy, but when it starts combining with the other features, it's kind of a nightmare, honestly. Like things would be so much simpler if we didn't have overloading. So, but given that we do, and it seems unlikely that we would get rid of it, I'm just trying to look back at the type checking situation because that's kind of the thing. I did a certain thing with the type checking that when I typed it, I was like, oh, this isn't going to be good, right? And it hasn't been good. I mean, it enabled us to do some things, but it has been sort of as I expected when I typed it. It has been a thing that has caused some complexity elsewhere in the compiler. And I really don't like the amount of complexity that's causing. So this bug that got filed, it was like, oh yeah, okay, we can fix this by putting in more yielding again. But like putting more yielding into the polymorphism, which is already complicated and stuff, I was like, nah, I mean, it's time to look back at this and try to figure out how to untangle the knots a little bit more. So that's what I'm doing right now. Explicit function overloading to limit complexity. I don't know what you mean by explicit overloading, but like the problem that you have is like sometimes you just want to import multiple modules and some of them have the same function. Like you could exclude that from one of the imports, or well, it just seems like a pain in the butt. Do we support some types? Every language since fucking C has supported some types. Why do people ask that question? Why? It's because people heard this idea some type and it sounds like rocket science. And it doesn't even make any sense. The term some type doesn't even make any sense. What even is some type? It's a union. Translating from trying to be rocket science speak, some type means union and product type means struct. That's literally all it means. They're just applying mathematical analogies where they don't even totally fit in order to make things seem more mathematical. You can specify what type overload maps to which function. What? I don't know how that works. Anyway. Like Fortran might even have so-called some types. Like that's how old they are. The idea is that it can have all the values of type A and all the values of type B. I mean, any way that I interpret it, it's a stretch, right? It's trying to be algebraic about things that are not really algebraic. You can't have two procedures that are the same name, but there's a new construct where you list a bunch of procedure names and aliases them to the same name. But that doesn't solve a problem. How does that help in any way? Because the problem is you call a function with some arguments and you have to figure out which one you're calling given the types of the arguments. It doesn't really matter how you decide what the different functions are. What matters is that at the calling site you have to undergo a procedure to decide which one you're calling. Do I think what every programmer should know about memory is a good paper to get better with performance? I think that's good background information. It's pretty old, if I recall correctly, so the numbers are out of date. Like the situation is more extreme than if that's the one that I'm thinking of. Yeah, no, listing things explicitly won't help. What would help is gimping the rules around what overloading is expected to handle, which it sounds like, given those extremely simple cases that you're listing, would also gimp the functionality. So I suspect it's really the gimping of the functionality that is doing the work there. You don't need to know memory nowadays? That is so false. Holy cow. Holy cow. Can I give a problematic example for the overloading? Okay. So the actual core, okay. So the fact that you have overloading means that you have to do all the argument sorting and type checking on every overload, right? And it's the type checking that's the complicated part, because type checking has to be able to yield sometimes. And yielding means, hey, we can't produce a result yet, so calling site, you have to be prepared to yield and call back later, right? Yielding is how this language does nonlinear compilation, and it's been a very effective way of doing it. The problem is that any function that could yield imposes a burden on the callers of that function, right? And so the thing you want to do is try to keep the yields to functions that are not called super frequently, and that you know what you're doing when you call them, and so forth. And the problem is type matching between two types just happens a lot, right? So if you have to be prepared to yield anytime you do that, it means all your calling sites kind of make a mess. So now, okay, so what does that have to do with overloading? Well, there are certain things I could do to remove yields. Okay, so if I want to get rid of this yielding complexity problem, then I want to be able to write the type checker without the possibility that it could ever yield. So it always has to have as much information as it could need to give you a result about whether two types match or not. Okay. Now, there's really only one reason having to do with nonlinear compilation, the original nonlinear compilation feature, why we would yield. And that's like if a struct is not totally compiled yet. And I think that one's kind of handleable. But there's a second reason why things could yield. Or a few more that have been added recently. And that has to do with struct or array literals and deciding what types those things are, because we sort of like retrogradely assign them types based on what they're matched with, right? So the type matcher sets, when you match a literal with no type designation, then needs to say, okay, this is a plausible, it's plausible that this array or this struct is of this type. Oh, but now we have to go do checking on all the elements to make sure that they really could be, right? Now, if we didn't have overloading, then the only time that you would be doing this comparison is when you really want to call that function, right? Or assign the thing or whatever, right? So, we wouldn't have to do the full type check on the struct literal to make sure it really fits the struct, right? We could say, oh, okay, you want to cast this literal to this struct type. We'll just do that right now and say it matches. And then later on, we can queue another check for later to make sure that what you typed is that literal really matches that struct type. But it doesn't really matter when we do it. We don't have to do it right now. We just have to do it before the program finishes compiling in order to make sure your program's correct, right? And that would simplify this core type checking thing. The problem is with overloading, it's not that easy. Because you're like, well, we need to know right now if this is a valid literal for the function you're trying to pass it to. Otherwise, we have to fail the overload, because if we don't fail that overload, our overload resolution process won't work. And we can't pick the right function because we'll have multiple overloads. So we have to actually do the type check right when you ask for it, which kind of sucks structurally if you think that things might not be ready to compile, or if you just have the system built. Like the way that we do the type checking right now is we sort of push it on this stack of what we're working on, and it goes on top of this other type checking, right? And then we yield back and redo that type check, and then it has the inferred literal, and then it can tell you if the overload succeeded or not, right? All this is more complicated than I would like to begin with, but that's just sort of this is why overloading is a pain in the ass, right? Because you don't actually know if the type check that you're doing is supposed to succeed or not for a program to be correct. Whereas in other cases, I'm pretty sure you generally always do. Anyway, hope that explanation helps. So I'm just going to kind of think about this today and look at the code and try to simplify things where I can. I had wanted to make this a sort of like a go off to a cafe and chill kind of a day and think about this, but then I decided not to do that because the only good cafes now, because California sucks, are like a 45-minute drive away from where I live. So I just didn't want to drive for an hour and a half to do that. So I decided to do the Twitch stream. I don't know how well deep thinking is going to work on stream. It probably won't, but I want to at least try a little bit, and then we'll just fix bugs and stuff. Pretty sure, I'm looking at this and I'm pretty sure that this can't actually ever happen. But I want to know. I want to know if that actually can happen. Let me make debug build so we see the assert. My theory is that it can't. What I'm kind of trying to do is remove yields and simplify and try to get it as close as possible to zero yields. Is the option to remove function overload on the table? I don't think it's practical to do that, but maybe. Like, there's several things you could do. You could remove function overloads. You could constrain them in some way. So one thing that I could do is add the following rule to the type checking, right? Hey, if you pass an anonymous struct or array literal, that'll succeed any overload and the type check happens later, right? So if you pass an array of strings and there happens to be an overload that takes an array of integers, that will just match and you'll fail later. Now, the problem that I have with that is that that's kind of unintuitive to the programmer. Now, we could give an error message that helps people out with that. but like we just want the type system to be as simple as possible. Like I want programmers to have confidence that they don't have to think that hard about what's going to happen, you know, or what's legal and what's not. And once we start getting into polymorphism and stuff, it gets a little more complicated. So maybe it's fine to have to know more. But for basic stuff, like I'm calling a function with an array of integers, I don't really want there to be surprises there. So the problem is that adds surprises. Somebody already said, we just talked about explicit overloading. That doesn't actually help anything. Like I said, explicit, like it doesn't help anything because the names are not the issue. The issue is when we're calling, we have to pick one. Yeah. The fact that they have different names doesn't matter really. So that's kind of what's causing the pain in the butt. But I'm just going to look at things and see what I can do. See what I could do to improve my understanding. Interesting. It didn't fire for any of the tests, but it fired in the Sokoban game. We could see where. I don't know that seeing where is really going to matter, but let's find out. Okay. Of course, it's one of these giant nightmare files. So what is the declaration? I might take a nap for a while and restart the stream. Shader binding model GL. Where is that? Okay. So line 269. So we have this using. My theory was that for this to pass the size pipe, this had to have also passed the size pipe because we're using it. Well, maybe it yield. Let's see. So it's yielding on the actual struct. It hasn't left the size pipe. Oh, right. Okay. So this is... Here we have one of those things where, because we're using it through a pointer, we're not waiting for it to size because it's a pointer. Probably. Okay. The thing is, we could actually fix that. I think. We could add a constraint that says, hey, you're not allowed to pass the size pipe if you're using some, like, yeah. That's doable. We would have to put a note on that this is why. That would get rid of this yield here. But we still have this one. And that's not necessarily good. Maybe some tea. I might do today without caffeine, actually. Just because I probably should do a no caffeine day just to renormalize. Let my brain chemicals go back to normal. So this one, how would I get rid of this one? I feel like if I could get rid of this one, the other one is not so hard. Let me get some water while I think. That's not very good. Seems like it would yield a lot. It doesn't, I mean, yielding a lot or a little is secondary. It's, you know, it's bad for performance reasons to yield a lot. This, you know, also, what are you calling a lot? But that's secondary. The primary concern is just the structural complexity of having to handle a yield at all. This is a little bit of a weird check. Okay, there's a fundamental tension happening here, which is the following. In general, even before you talk about overloading or type matching or anything, you have this thing in languages like this where you have structs. They maybe want to point at each other, right? And you want to be able to know what the type of each struct is and what the size of each struct is. And, well, because you don't need to know the size of another struct in order to have a pointer to it, right? That's taken into account in the type, whatever you want to call it, the type generation system that figures out what the full type of the struct is. It knows that it doesn't need to wait for the other struct to be complete because it doesn't need any information from that, right? That's the thing that happens in C. It's the thing that happens here. Because if you don't do that, then you couldn't have two structs A and B that both have pointers to each other, which you really do want to be able to have in a lot of cases, right? So, that's one thing, is that it seems very important to have that be part of the type system, is to not need to wait for the other struct in order to know the size and type of your pointer, which then lets you know the size and type of the full struct. On the other hand, the fact that you're letting that slide back there so you can do these, you know, circular things, means that you maybe are setting yourself up for a yield later on, because now if I have a struct and I need to be able to inspect its members, and one of them is through a pointer, then that may not be done because we explicitly decided that it may not be done earlier, right? Now that said, there is a middle ground thing that I'm thinking that could maybe help simplify this, which is so, in other stages of the compiler in times past, we would do so for example, when we were trying to look at the call graph, right? And you say, can these functions run yet? And you can have functions that call each other in a cycle, right? Well, what you do is you notice if you have a cycle that's all waiting on each other to pass this part of the pipeline, and then you say, okay, well, you're all just waiting on each other, so we're going to pass everybody in that cycle, right? Could do something like that for structs. That sounds complicated, but it's isolated complexity, and it removes that complexity from all these other things. So we could say, look, if you have a pointer to some other struct, you can get through most of type checking, but then you're going to go into jail at the end, and you're not going to be able to leave jail until all your buddies are also in jail, right? That would simplify later stages of the compiler a fair bit. However, then there's other stuff. There's other stuff that might not play well with that concept right now. Oh, maybe it would. Maybe it would. Maybe restructure things so queued is always true and pipe check is stuff that the if is never true. Gosh, I didn't think of that. What are you saying at me? What are my thoughts about trade-offs between right to left evaluation? I don't care. I don't want to program in stack HP calculator notation. I don't like, if you want that, cool. There are languages that work that way. Does it need to be an analytic detector of cycles? Pretty much, yes. We already have that code, but because C++ is so bad, the code is pretty ugly to genericize. So I have two different pastes of it. But we could use that cycle detection code in this other thing. That would be a little mini project that I don't necessarily want to do that today. But so today I'm just like thinking about this. I kind of like that idea to a certain degree. If that completely solved the yielding and the type checker problem, I would at least be hyped enough to try it, right? That would solve both of these yields, which is good. The thing is, we still have the anonymous struct and array yields. Or not anonymous. It's confusing terminology, but the literals that don't have type designations on them, those are still a problem. I'm just trying to think for array literals. It's maybe easier. Not really. So we come down to this question again that we actually need to be able to fail the overload or not in those cases. That said, I mean, I don't know. I'm thinking like maybe there could be a way to have it be bimodal. This adds complexity, right? But like, hey, if you're calling this from an overload, we go do the whole check now. Otherwise, we don't. That doesn't seem very good. Okay, here's the thing. The reason we yield in these right now is because I sort of push the work unit for type checking that struct or array onto the stack. Because that was just the easy way to do it. And because that involves type checks, right? However, well, it involves type checks, and we know type checks could yield, right? But here's the thing. There's this kind of information destruction that happens as programs get bigger, right? And that makes things hard to understand and hard to work on. Is like, okay, our type checking routine, it takes a yield parameter so that you can yield. And therefore, when you're a caller, you're supposed to pass a yield parameter. But not all type checks need to yield, right? There's some subset of them that definitely will never need to yield, but it's hard to understand which ones those are. If we can know, for example, that when type checking an array, we can always do that without the array yielding, then we're pretty good. Then we could do it differently, right? When you do the type match, we could just do the full check. This is something I'm worried about though, because like the full check, like the check's going to insert casts, I guess, which we don't want. Let me see what happens. So here's where this happens for, this is for a struct literal, right? And then the array literal version is down here. And we do this array literal info part 2. All right. So we do a push and flatten. It's this whole thing that we do. And that's sort of where the yield comes from. This doesn't yield, but we push this and then yield so that this work can happen. I'm a little confused. I guess here's where the type check happens here. Let's see. Let's look at this. If it's an array literal, if we're waiting for type binding, that's this thing that we're talking about when it doesn't have a type designation. So this is where we generate that. Otherwise, we should not get... Where does the actual type check happen? I think it doesn't actually. Hold on. Let me... see, this stuff's complicated. It's hard to think about. It's hard to think about. Okay. What is going on with the off-topic chat questions today, guys? Okay. I mean, I'm pretty sure we type check array literals. That would be pretty bad if we didn't. We would need to fix that post haste, pre-haste. Right? So first of all, do we check this? Yes. Yes, we do. We also, I'm sure, test this. Okay. Where does that happen? Because I'm confused about that right now. Also, I should rebuild the compiler because we changed the line number on some things. Okay. Infer type for array literal. Oh, it's the part 1. Oh, because we get to the literal in the push and flatten. Right. Wait. What? Anyway, so we go through this. We go through every element. We do check that types match. And of course we have to check for a yield because nightmare. Not really nightmare, but I would rather not have to do this. Wait, I don't know why we're asserting. I think this is old. That doesn't make any sense because we just compared it. I think this is what we originally said, and then we're like, no, we're asserting, so whatever. See, the problem I have with this, there may already be a problem in the compiler because this is inserting casts. So in like an overload situation, I feel like something bad could happen. Okay. Let's get rid of this line because it's bothering me. Since when am I delivering T? Well, I didn't say, I said and also T, but the T is probably just for me, if I'm being honest. We could do some ChiCam in a little bit. It's been a long time since we did the full ChiCam. Okay. So maybe I am going to drink some caffeine today. I need to get going. What if I make the really nice, tasty chai tea, not latte yet, but with a little bit of milk in it and the honey like we made? I think that'll be good. Anyway, so yeah, I would like to have a much better solution for all these issues than I have. Okay, I'm worried about, let me just shrink it down. What I've talked about encompasses several scenarios. I'm going to shrink it down, shrink the universe down right now to just worrying about array literals and what happens with overloads. because I think it might be bad anyway. I think it might already be incorrect. And if that's incorrect, then the current structure doesn't solve the problem. And then, I mean, obviously it's important to solve the problem correctly, right? Or to redefine the semantics so that things can be correct. So I'm just going to focus now on array literals only. This bigger issue about trying to get rid of yields from type checking is still an issue. That's the long-term issue. But sometimes if there's like 5 things in your way, all you can do right now is get rid of one of the 5 things and come back later for the other 4. So that's what I'm thinking like right now. Do I ever drink coffee? No, coffee is gross. I should get rid of some of those wires. How's that? Oh yeah, oh yeah. Okay, that is a cleaner image, more respectful of the T. I mean, we're sort of catching the thing off to the side there is part of the tripod that is this main camera. So that looks a little weird, but we'll leave it for now. Table's getting a little messy because I spilled milk on it and it's dried on the table. we could put the chai packet right side up. Just boiling the water for a second. Okay. Now, my theory is, let me think about my theory before I go test it. My theory is that array literals are handled incorrectly because we type check the literal before returning from the type query of whether these types match. And type checking the literal involves, no, this is actually not true. I was going to say, and type checking the literal involves inserting casts, and if we're doing this speculatively on an overload, it is not correct to insert those casts. Now, the reason I actually think that's not correct, or that what I said is not what's happening, because I don't remember, because I programmed so many things, right, that I forget how they work. Or maybe it is what I said, but because of that, it's even more incorrect than I thought, right? Because the problem is we need to be able to return false that like this thing doesn't match, right? And this thing for this array literal part 1 that we were just checking, looking at, it can't silently fail. It only reports errors, right? So that can't really be what's happening, or if it is, because overloads need to silently fail, right? The way that you decide not to pick an overload is you say, is this the right thing? And you try it out and you're like, nope. So I just need to look at this a little bit more so that I see very clearly what is happening. I'm confused about how we ever get to here. Like, I see how we get to here. So we infer the thing, we hit waiting for type binding. Let me just see what happens. So we have this array literal. We're not even going to import basic. We're going to try to keep it down. Maybe there's no other array literals. Okay, so we're just going to set breakpoints here and here. We're going to see what happens. That's in the preload. Okay. String to float. Oh, because that's in... yeah, never mind. Okay, so here we go. This is the one we wanted. So we're seeing the array. We're waiting for the type binding. Okay, because it's an... that's fine. Now we're here. We went to the type query, all right? We clear out this type, this dummy type of void that we set. We call this. This is the place that I'm talking about where we need to yield. Let's make sure that we do that later. So this pushes stuff, this I mean that we're in right now, pushes a bunch of expressions. And then, right, if we're hardening a literal, we yield. And this that's highlighted in blue is the part that's sort of causing a butt pain and like a lot more complexity than we would like. So if we can just solve this for array literals, that's a little bit beneficial. Okay, so we're down here in this part 2. So we push the elements. This statements in order is all the elements of the array. But like, I don't see... we would have to get back up here to check against these. So that's what I don't know, is how we get there. Wait, did I remove the breakpoint? Anyway, This is the part that I don't totally understand. All right, let's investigate the T situation. I put too much in again to add the milk, so I'm going to have to get rid of some of it. But it's a dilemma because the best, most steeped tea is at the bottom. So you want to pour all the way to the bottom to get the rich flavor, right? But then you have too much. It's terrible. Okay, we have a good tea situation. Okay. Now, we are back to thinking about array literals. How is it that we are here? It's because we're here. Because we're looping. I apparently deleted the breakpoint for some reason. Oh, no. That was the array literal info. Right. Yeah, okay, it's confusing. Anyway. I guess. Hmm. Really good tea, though. Really good. So I feel like this whole thing that's happening is not good, but I want to finish tracing out my understanding of it. I think that what we actually need to do, I was trying to avoid this, but I think that when we infer an anonymous literal, I think we actually need to make a new literal that has the type bound and substitute that. And that could be very expensive for large literals, but it's kind of what needs to happen. The good thing about that is that I think if we do that, it becomes feasible to do the delayed checking that I was talking about, which would remove the yield. So, and also we wouldn't have, I kind of like that on basic principle of just having like less crazy stuff going on and less like, anytime, this is one thing that the functional programming people actually get right, like if you fill out results that people expect to look at, but then you go sneak in and like change the results later, it can get confusing and it can make things bad, right? So I think that is a thing that we're going to want to do. Let me just keep looking at that and I'll build up my understanding. And then as soon as I'm clear at what's happening here, we could take a look. Now, all that said, I'm not sure what the equivalent is for array literal. We would have to look at that, or for struct literal. Struct literal seems less straightforward. Okay. So, as I look at this and get a clearer picture of what's happening, I just want to think through a couple things. I suspect overloads already don't work with array literals because the error is happening at a later time. And the infer step is happening in a way that's permanently inserting casts into the literal. So there's a lot to think about in a programming language like this. is my current project on GitHub. Lol, 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 lol. Tra la 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 lol. Lol. Okay. This tea is really good. I may just become a full-time tea streamer and stop the programming, you know? Is it too much friction to have struct and array literals have to specify what type they are? We already had that. Like, what we're trying to do is maintain the higher level language features that people enjoy. All right. Yes, we could require that you always put the type, but it's a butt pain as a programmer to do that. Syntax doesn't matter. The question is just whether you have to do it or not. And in fact, well, let's not get too much into it. Okay. So the thing that's a little bit confusing about this is there's two things. There's the array literal and the array literal info. And the array literal info is an internal accounting structure that we generate that the user doesn't know about. And we just use it to set up this kind of type inference stuff that happens. And so the thing I think that was confusing me before was I was looking at infer for array literal info and forgetting this part. Okay. So now this is back in the, so here's what I'm not sure about. Okay, we go back here. First, we hit this, and that was fine. And then we did the check that types match for both of these for the equal sign. And then we pushed this. We saw that happen. Actually, this is weird. So this has a waiting for type binding equals true. Hold on. But this, okay, this checks it. Let me look at what we do in the flatten. So if it's an array literal, first we put the info. And then we put the array. Okay, hold on. So the check that types match. Oh, this is the wrong. Let's run this back. Okay. So this is the array literal info. This is part 2, which is being called directly because we skipped it there. It's being called here. Now we're clearing the type off the literal. Okay. Right. So now so we clear the type on the literal. We say hardening literal, which causes us to yield. Okay. We yield from this, which is the declaration. This is a little bit different because I made it a declaration instead of like an overload resolving procedure call. So we're going to yield from that declaration and go do the stuff. We're going to infer all the... I kind of don't understand. The next part. Because the elements of the literal should already be inferred. So like this is the part that I don't get. Okay. So we go to reset flattened right there. Because we realize that we pushed something new. Now we're going to infer types for some expression, which is a number literal because it's an array literal holding some numbers. Oh, we didn't have types for it. Interesting. Okay, so then if we go into typer, Um, okay. Now, so this is the same one. It's at the same indices. Now its elements are inferred. Now the weird thing is we just inferred them to S64, but I think that's the unhardened, right? That's the unhardened cast situation. So we're going to go down here. Not there, but not there. Come on. All right. Not there. Here we go. Okay, so here we go. We're comparing number against number. And this is an unhardened literal. Boom. So we're going to insert a cast here. Yeah, what a spam this is. So we're going to return true there. None of this is happening anywhere near the actual infer of, or the check that types match for the assignment that we did, which means if it were a procedure call, none of it would be happening there too. So like, I'm pretty sure. So if I make two functions that take an array of different sizes, right? I'm pretty sure I can get it to error on one of them before it finishes type checking all of them and says, hey, there's more than one possibility, right? That's not the worst problem in the world, but it's not good. Let's see. F takes an array of U16. There's another F that takes an array of U8. And then we'll make a U32 and a 64 just to give us lots of possibilities. And we're going to say F of this. Now it should be, let's go 300. Now, I don't think this should work no matter what, probably, but I think the way in which it works is going to be confusing and wrong. Except it worked. Okay, what did it do? Okay. There we go. So this just has to do with whatever arbitrary order it's doing these in, right? Like it should say, hey, there's 2 possible overloads. Or there's 4 possible overloads, depending on what the overload rules are. But it doesn't say either of those. Instead, it says, hey, in this one that you're not even, these might even be in some other file that you don't know about, right? And you're saying, I'm calling with a 90,000 there. And you're hitting these for some reason. And you're like, no, I was just trying to call this. Now, the reason this is so, well, I don't know. It at least tells you where one of them is, but it's just a horrible error message for trying to understand WTF is happening when you're confused. Now the question is there any case in which this actually generates a fully incorrect result? I'm not sure that there is, but it's sort of only by accident. Because the thing is, we're inserting casts every time we try one of these overloads. So let's say we even do one that works, right? Or, I mean, this should say 4 overloads. No, I don't know why that works. What? I think what this is doing is it's getting casts inserted on it. So we do overload resolution with like cast counts, right? Or what? Like there's several things that can make an overload less specific or more specific. And that's a thing I'm a little bit leery of as well. But I think what's happening is this is the one that we try first. We end up casting this to that. Then this one doesn't cast at all. Or no, I guess whichever one we try first, we just overwrite the type in the literal and then it's GG's, right? So if I do this, yeah, that's just not something that we can have in this language. And I didn't realize it was this busted. Why are global variables not bad? Because sometimes for portions of your problem, the simplest and most robust solution involves global variables. Can you print the overload scores? No, because what's happening here is not even about the scores. What's happening here is it's a generalized literal, and then the first overload we compare it against, that like glues its type to the literal, which is not supposed to happen. And then from then on, it no longer matches any of the other ones because it's specifically typed, right? That's what's happening here. So that's very bad. So what we really want to do is make a new literal. In cases like this. Now the thing is, sometimes maybe we don't need to make a new literal But we could worry about optimizing that later, I guess. Correctness is important right now. And this is not correct, and it's going to be very confusing to people trying to use the language if we don't fix it. So what we will do instead is we'll make some new function for hardening an array literal. I guarantee this is also happening with struct literals, by the way. Or I don't 100% guarantee, but I like 93% guarantee because it's very similar handling. So step one is to fix this problem. But then step two is we'd like to get rid of the yield. Is the correct behavior to error and say ambiguous overload? Yes. It should say there are 4 possibilities for this overload. Here they are. In fact, to show how absurd this is, we could even take the 1 out, and it's still going to call one of these guys just fine. Not good. Not good. Would it still do it if the first overload was a string? I mean, you'll go back to the other behavior we showed before, which is that we generate an error later. And the overload fails for a different reason. So if we do this, right, and we do this, see, it's just, we shouldn't be modifying the literal. That's just not good. Okay, so this is going to be good. It's, again, it's going to be maybe slightly slower, but probably not measurably so. And if I follow through on it correctly, it'll remove a bunch of complexity from the anonymous literals anyway, which is a welcome thing. Not exactly what I thought I was going to be working on today, but definitely relevant, because if we get complexity out of that, that's a significant reduction in the complexity load that the type checker is bearing right now. And that is what I eventually want to get to. Okay. So solution, first version of solution is we don't what is first version of solution? First version of solution is, yeah, we just copy the literal and return that as a substitution in the switchable expression slot, which means the switchable expression slot has to be provided, which hopefully it is all the time. The first thing we could do is assert or compile error if we don't have that. Switchable expression slot is how we give back a new value if a cast needs to be inserted during type checking. Okay, so here, we're going to say I guess we maybe already check. We're using it here without checking it. So yeah, okay, we check it out here. Yeah. This should actually be internal compiler error. That's not really a user-facing error. Okay. So we're already checking for that, and it doesn't happen, which is good. So the next step is just to copy the literal. And I have a function called copy literal. I guess I feel like I vaguely remember modifying it to handle array literals, which it didn't used to do. Copy literal. Well, that's not really. Okay, and none of these really do it. Oh, I guess we generate the array literal info when we flatten it. So I think we just copy the literal. Hold on. Let me look back at the flatten. So that's already set by the time we get here. So I guess that's in parser. So we make an array literal info. We have an element type expression. We have the values. Okay. So I'm just going to go make a function here that says I'm a little worried about that. I don't want to think about too many things right now, but this is like a different thing that's happening. Okay, so this one is where we're modifying the old thing. And we don't want to do that anymore. We want to make the new thing. So we say, new literal. Let's just say hardened literal. Okay, and here we're going to say literal and element type. Okay, come back and steal that code. And then we yield on that. So I'm worried about this here again, because we're referring to old literal, right? We're going to move a little bit of this code in a second. Let me just do this, and then I'll go back to it. My brain just wants to do this part, even though it's simple. Okay. Let's just do is it called that? Yeah. Okay. Whoops. I forgot to paste in this. Okay, waiting for type binding is automatically false. Resolved element type. We'll set that as well, just to... and then input expressions. Okay. All right. So that's all we do there. Oops. Let's just do this. All right, so we go old info arrow. Okay. Now we do this, we do that. Down here, I don't know. How to be this productive for such a long period of time? What are you saying the long period of time is? Do you mean the 2 hours that we've been streaming? Because I've mostly been goofing off during this stream. Like, your definition of productivity may be in trouble. Like, we were just chilling and making tea and talking about stuff. It wasn't that productive. Okay. So the thing that I'm worried about is here. Because we're matching the old literal, but we may have subbed this in. So I need to see what this is for. Okay, this is literally just the site. Okay. That is a relief. I don't have to do something complicated for that. However, down further, we do. I mean, this is kind of gross, but okay. Okay. So that will solve one of these problems if I did it right, which there may be bugs with what I did, but it does not solve both problems. This string thing is still going to cause compilation to fail. It's just a question of whether that error happens first or the multiple overloads error happens first. Because we haven't changed the thing about this possibly being a silent type check. Anyway, now that we're making a new literal, this actually makes, well, no, I don't know. There's like at least 3 different problems that we need to deal with. So this is one of them. All right. So what's happening here is we're setting up the type check to happen later. Oh wait, no, we're not even pushing it. No, hold on. We are. I'm actually not sure why that doesn't frickin' fail. I feel like that should be failing on the string. But at least now we get the multiple overloads, which is never something that we got, but I don't think it's for a good reason. So if I comment this out, what if I comment all these out except for one? All right. There are no elements in the array. So I failed to copy them correctly or something. See? Or we're not inferring the thing correctly. I was thinking, like, why would it not have failed? Oh, if the array is empty for some reason. So the copy, the hard and literal function, not really working. So why? I don't know. All right. So we're going to break here when we make one of these. Should only really happen once. Okay. Let's make sure. Yeah, okay. So that only happens once. So we actually know the type of this. Anyway, let's just make sure. So this goes, we say, oh, we're saying for single expression. That's not good. That's actually not good. That's why it's failing. That's not good because it's not. It's not doing the array literal info. Okay. So here we're going to say hopefully that's good. Dang it. We don't have an enclosing scope. What? We do on the... Oh, this is the struct literal version anyway. Okay. I think it's stored in the array literal info. Enclosing scope. All right. Let's look at this, by the way. Not right now, but while we're working on this. Okay. So, I forgot the values dot. And that's an arrow. Okay. It really doesn't like that. That we don't have a type. So this is, okay. Well, let's see. Who's not getting the type? It's either the literal or the literal info, or maybe it's one of the elements. It's the literal. Okay, now, assuming that this yield works, then okay, so we yield from here. Just type check arguments helper. And then we come back sometime later. Which means we pass the literal without ever inferring it? That's not good. So we go in here. We add source exp. Wait. Does copy literal copy that? Wait, what? Why are we flattened within? Because I pushed the new literal, not the... Oh, God. Guys. That was not a 10x programmer move. Okay. So now we're back to still not good. Well, I don't know. You know, okay. So if I do these, we still have this, which is actually the right result. Okay, that's better. I feel like this is going to error, but it's kind of arbitrary what order they go in so far. Yeah, okay. This is obviously not really correct either. Now, the reason why this part is happening is that thing that I was saying about overloads needing the result right away. So the question is, what do we do about that? Okay, so let me just think about this for a little bit. This particular error can be fixed somewhat easily. And the way that we would do that is we would put a flag on the literal that says, hey, when you type check this literal, we're doing it speculatively for the purposes of an overload. All right. So if it doesn't match, just chill and don't report an error. And that flagging is something that we already have throughout the type matching code. So we can just use it and it's no big deal. However, I kind of would like to do something else if I can. I'm just not sure that there is anything reasonable to do. Something that would enable me to do the full type check later, like later after we return from the overload handling would be the best. But again, the problem is if we don't check the type at all, then you won't reject, for example, the string overload versus the int overload. Like if we just had those two, which you want. We could I don't know. Array literals of integers are the simple case anyway. The reason why this gets hairy is like, what if there's a struct in there and the struct has to yield, right? That's like the real problem. Do you only have one integer score per candidate function? We just add the scores from the individual parameters. The scores are designed to add, right? Okay. Anyway, this is an improvement so far. So that's good. I'm just trying to think, what do we do about this thing? So, for example, the following case should work correctly, right? It won't right now. But this absolutely should work, right? If this doesn't work, then why would anybody use this programming language? Actually, there are lots of other reasons, but still, we should make this work. Or maybe not. I mean, we could always say, look, you just have to do that. Like, it is a policy option that we could say, look, if you don't say the type, then you didn't say the type, and that's what you get. That would make life easier, especially when it comes to struct literals. But what I'm worried about is the struct literal case. Oh, I just realized the way that I was copying this literal hides a little information from the metaprogram. Maybe. We'll have to look at that later. U32 versus string seems like it should just work. Well, okay, so the error message is definitely not good, but I'm taking it seriously as an option that we could just say, hey, look, you didn't specify the type. There's two things that take arrays. I know it looks like it matches one of them, but you have to specify in a case like this. That might be too limiting. But again, it would simplify a lot of things. And the value of that simplification is not to be underestimated. So, what do we do about that? can you pass an auto-casted thing? I mean, that wouldn't really define the type, so no, it doesn't work. $25 months. That's crazy, man. Man. Okay. Option 1. We punt on this type check for anonymous literals and say you have to specify. That gets rid of multiple things. It gets rid of the yielding problem. Well, and maybe it makes other things simpler in the future. I don't know. Okay. Option 2. We do the type check right here, which is nicer for the people because they get things to work more like they expect. However, it creates this yielding problem because we have to say which overload failed. Now, that said, we might be able to move the yield, right? So it's only in the case of having to distinguish multiple overloads that we need to do this type check to do that distinguishment. Otherwise, like I said, it could happen anytime, right? It could happen later. It has to happen before code generation, right? But aside from that, you're fine. Well, it has to happen before messaging. So we could instead say the following thing. We don't check the elements in this check that types match. We return the new array that would eventually need its elements checked, maybe. And then, if it's a routine that needs that information to distinguish what's going on, such as overloading, then it is that system's job to notice that it got these and then set up the infers as necessary. That sounds a little bit more complicated, but it's actually better because it shifts the complexity out of the core type checking into the couple of specialized places that need to worry about this kind of thing. And that's way better, actually. I kind of like that. And if we could do that for both arrays and structs, then that leaves only the compatible anonymous member check that we were looking at the beginning of the stream. Which could probably be handled by other means. And then we could get the frickin' yield out of the type checker, and that would be so good. That would be good for everybody. So I'm motivated to do it. Is function overload that useful? I think it is. I don't know. It sure is causing me a lot of pain, but I think it's worth it. Okay, I like that solution. Now, either way, whether we check this later or check it now, we need a way to say, hey, array literal, you're not real. Like, again, don't be loud if there's an error. And I think we can do that pretty quickly. So I think if I do that now, then we could run tests on this and check it in, and we'll have fixed this particular problem, which is good. We can add the repro case. And then I can start thinking about getting rid of the yield situation. Although honestly, the solution that I was going to do in the meantime for getting yield out of the well, I don't know. Anyway, one thing at a time. So let's make this work better. And then, assuming all of that happens, I can look at struct literals, which are implemented very similarly and probably need the same changes. Okay. On literal info, do we have a flags here? We don't. We can say, oh, that's struct literal info. Bool silent check. We'll just call it silent check. That's what we call it all the time. Okay. Harden literal. All right. All right. Okay. So the part 2 actually does these checks. Now, do we ever call part 2 array? Let me just search that here. Array literal info part 2. Yeah, we could factor that back together. Because it doesn't do anything useful. Actually, let's just, no, let's not worry about it. So here, I guess it's array literal parens. Okay. This becomes info arrow silent check. All right. Although honestly, okay. Beep. Okay. So now we have matches multiple possible overloads, which is in a sense better because it's not saying type wanted string type given S64. It's saying, hey, we match both of these. Now we don't actually, right? See, the thing I don't like about this is that it's going to be really annoying to tell. Like, what if you make a mistake? If you have a function with like 4 overloads and you make a mistake like out in number 17 on one. All right. Anyway, so when we fail the silent check, okay. we're going to say if we're not matching, then we're going to say if info silent check just I. Okay. So we go back here and we can use this information to know that it failed. All right. Okay. Okay, so what should happen is we set the substitution. Okay, we need to know that this failed for one of the overloads. And we don't really, okay, I can force it to fail in the following way. Let me just start this going. We can like set it to like something bad, right? Oh, that still doesn't work. Hold on. Okay, we got to remember to compile. Okay, so we get the cowabunga, but oh, maybe return true here, because we're resetting the type later. It still doesn't work. Oh, maybe we have a substitution. I don't know now why. So we're setting the type on this to void, which should not match an array of something. So I'm a little confused. Well, okay, so we're in check that types match for this. The site is this. So we should come back here later with the same site. Now maybe we don't, but we do. Okay. It's a literal. Wait, what? We already did this. Oh, because it's a different overload. Right. Oh, the site is going to change. Yeah, hold on. We need to check for the site that is equal to new literal arrow s, which is this one. Do we ever get here? Doesn't look like it. Okay, how about this? We're here. Come on back up. We yield from this. Okay, now what happens next time we come back here? Right, so we're on I. Argument 0, right, because there's one argument, of this call. So we're back there. We're argument 0. Now the new type given, this should have been substituted. Oh, now it's a cast. That's why our site didn't trip. We don't need a cast. We don't need a cast because we're making a new literal. So that's a little bit wasteful and excessive. Okay. Okay, so if hardened literal, else, right? We're going to do that. Here, we're just going to go here. Okay. That worked. Now, it's not a very good, the thing that I did of shoving void in there is not a very good solution. And we're going to need something better than that. Where did I put this? Silent check, matching failed. So if I take that out, then we freak out. Oh, we didn't ever set a type at all because I returned. Let's just take all that out. Yeah, so if I take that out, we still match. What we need now is a way that says, hey, buddy, the matching failed because, like, element 17 didn't work, right? Because otherwise this is error message from hell because your overload fails because element number 349 isn't in range. And you're like, WTF. You have errors from hell once in a while in C++. Well, that is no surprise to anyone. C++ compilers are not the best. If you're passing that many things in an array literal, you might need to rethink your program. You have not looked at some very serious programs that do some very important things then. Because some of those programs have big array literals in them. And if you typo one, it's not good. And then the other thing is we have to make sure we didn't ruin the vanilla case of what happens when you're not like doing overloads and stuff. Of random magic numbers, yes. Absolutely yes. Some of the most important code in the world is like that. Can I recommend any publishers? No. Not game advice like marketing, PR, and such. Okay, here's the thing. Most of these publishers are not actually good at those things. Like the indie publishers, for the most part, there's one or two. So like Devolver actually does good marketing. Every other indie publisher that I've ever seen says they will help you with marketing and then sucks at it and or just doesn't do it. And then they're just throwing your game over the wall and seeing if it makes money. Because if it doesn't, it didn't cost them anything, right? Here's the thing. Okay. Here's a more important comment. You're setting yourself up for failure with this attitude, which is the following. You're like saying we don't want to ask for money. We just want someone to help with this kind of stuff. And the thing that you have to understand about publisher dynamics is if they don't put any money into your game, they don't care about your game because they have nothing to lose. All right. If they invest money into your game, they want to make that back, so they will actually promote it. If they don't invest money into your game, what do they care? It's just like a free lottery ticket. So you should, if you sign to a publisher and give them any kind of substantial revenue stream or rights or anything, make sure you're getting a lot of money for it, because they have the power to ruin your game now. And why would you give them that if there's not some upside? I mean, everything likes array literals. Hash functions like array literals. Um, Even like the SIMD parsing stuff that Casey did had array literals in it. Yeah, like going to a publisher like that and saying, "Will you help us with marketing and PR? And for that, we'll give you 50% of our revenue." That's a losing deal for you. Like, you are way better off just learning how to do marketing and PR, which is not that hard because there are agencies that will do that stuff. So you just pay those people and they will do the things. Probably better than the publisher will. Because when the publisher talks to those agencies, they're talking to them about 10 different games and they don't care that much about your game. But when you talk to those agencies, you're talking about your game. It matters. Okay. Yeah. An anonymous untyped one directly in a function call. Well, that's a little different. It's true. That is true. Okay, so I'm trying to think about how to report this error in a good way. But maybe that comes later anyway. Maybe that comes with the part that is about like what I said about moving the yield and doing it in bulk, like after the thing. Because that's the only time silent check will be true is during overloads. What's the value count at? I don't know. We have some values to give to the people, but none of them are huge. They're all little bug fixes right now. And then I started doing array literal stuff and realized it was broken in ways that I didn't know about. So we're working on that. This is the current value proposition. Suppose publisher is the wrong word. Really, the value would be with someone who is a PR person. Since you aren't interested in giving other people revenue percent or control. Yeah, then you don't want a publisher, because publishers won't talk to you if you're not giving them a royalty or ownership. They're not interested. That's their business model. So you don't want that. You just want to go talk to a PR firm or a marketing firm. Keep in mind, those are two different things. They have different jobs. Yeah. Okay. So how much do I worry about this? I'm going to put a note here, and I'm going to link it back, because again, we're working on facets of a bigger problem. So I'm going to say bad error message will be produced here. Okay. Actually, we only need to do this. Force a type check failure with a bad error message. Okay. So this is the bad thing. And then here we will say when we do an unhardened array literal type check in procedure overloads, we don't currently report to the user which array element caused it to fail a type check, which may be very bad if no overloads succeed. But this may get naturally fixed in the process of removing yields from check that types match. Okay. So I don't feel too bad about this, because the picture that I was thinking of about removing the yields would apply to this as well, because, you know, we can go over, like, hey, we can say, oh, we still have multiple overloads. Are there any array literals that haven't been type checked yet? Okay, check them. And then when it's time to report error, because you're looking specifically at that stuff, when it comes time to report the error, you could say what happened, right? Like, that all makes sense to me, and it's not too bad. Okay. Actually, this one is the one that seems hard now. But maybe it's not actually. Maybe we just don't let the enum pass type checking in that case. Like if we do the same putting things in jail that we were going to do for structs, enums could go into that. I guess. Maybe. I need to think about that. Man, programming languages are kind of hard sometimes. That's all. Okay, so we're going back here. Let's make sure we're... Okay, so this runs. Now, so this should say, we don't know which overload you want. Yeah, that's fine. That is good. It also excludes this one, which is good. We don't have cross-contamination between the overload attempts, which is good. Oh, I want to go write a comment explaining that that's why we're copying the literal. Okay. If we do something like the following, now we're going to get a bad error message, I think. Whoops. Yeah, it says type given void, which is not helpful. But like I said, I think we can improve that error message later. Okay. Okay, this actually was going off. Okay, first let's run tests, because I could have broken something real bad. It looks like I did. It looks like we have an infinite loop. Sounds awful. I probably should have done that sooner. Dang it. Let's just let it run for a while. And then I bet if I put a breakpoint back here, we're still spamming new literals all the time. Why is that so bad? Okay. Well, dude, these cinnamon cashews are so good. I gotta stop eating them or else I'll be mega fat. All right, that's enough. Okay. Wait, why do we have a breakpoint here? So we keep casting the same literal, which is weird because we supposedly set the switchable expression. So what I think is the calling code was probably incorrect in that it's ignoring the switchable expression. It's just, it didn't matter that it was incorrect before because we were poking the thing. This is so weird. All right, we're going to yield. We're going to come back. Okay, this is going to get changed. When we do this switchable expression right here. Oh no, because it's not live yet. So it's when we return, it's going to change from E830 to something else. Right? Yeah. So that's our new literal. So we keep making new literals and then they never are good. Like, wait, why? Waiting for type binding is false. Let's just see next time. Next time. Wait, why is it waiting for type binding is true? Wait, this is a different one. Hold on. What is going on? Like, here it's B77. Now it's 55DE. We yield. We continue. Now it's B77 again. Oh, we're resorting up here. Yeah, we don't. Oh, fuck. We don't handle yield correctly. See, now I have to do extra work. That I'm going to undo later when we get rid of yields. All right, let me start writing down the value for the people. Fixed errors in return statements, not properly handling internal yields. That's not going to make sense to anybody. Fixed fixed array literals without type designations. Fixed some bad between and procedure overloading. Okay, so I'm going to have to handle the yield better just so that I can come by later and unhandle it. All right. So, gosh darn it. So only the first time we come in here, we will sort this. Except, fuck, that means we can't keep the varargs info. Guys, I tell you, what a pain. What a pain. Varargs. Oh, we didn't even need it, though. You know what? Yeah. Never mind. We don't use that. I'll prove it by putting it in this tiny scope. So we sort the arguments, and then we say the cursor is 0, and then while that okay. And then give that a short name. Do that. Wrong key. Okay. I don't remember if that was supposed to compile or not. Yeah, it is. Oh, yeah, because we fixed our infinite loop. Okay. Can we build the tests? Yes. Invalid thread index. That's not fun. I really messed something up then. Same exact error. Huh. How did I do that? So it's saying 32759, which happens to be a 16-bit minus 6 or something. Okay. So we'll print out the group and make sure that's not messed up. Oops. Oops. I didn't put, look at all these things. Okay, pin thread 3. Oh. Why is that happen? Wait, what? I thought I didn't see that before. Maybe I just didn't recompile it. So we are passing 32759. Okay, why is that happening? Because we have an array literal or a struct literal. Which one is failing? Module test. Wait, now we didn't get it. What is going on? Now it's just dying in a different way. Did I mess up varargs? No. Because you can't return varargs. So that varargs info is just a thing that was there. Like it's the, you can call that argument to sort different kinds of, you call that function to sort different kinds of things. So that was only there for one of the kinds of things. All right. Um, so either I broke return in some way, or I broke literals in some way. Like this is an array literal out here. But it's one that has the type on it designated, so in theory we didn't break it. However, there are anonymous array literals in here, but none of those are the thread number. So I'm not sure. It's not called name. What is it called? File. Deprecated. All right. Is it always this one? So this one doesn't have a pin thread at all. It's always that one. Oh, no, not always. Wait. Yep. So this one is getting messed up. It's like the first one that has an errors array with more than one item. Okay. So that's a clue. It's not a very easy to debug clue, because what does that have to do with getting our pin thread wrong? That doesn't make a lot of sense. Okay. I could dive into this and start hammering on it, but I would like a more debuggable hint about what I broke. One thing that I could do that I'm considering right now is I have my laptop right here. The laptop has a fresh version of the code. I could update it and I could reproduce the thing that I just did to the return statement and see if that breaks anything. To optimize storage usage, Microsoft has turned on Storage Sense for me. Go jump off a cliff. How do I... Oh no. I'm down to 74 gigabytes. Better turn on Storage Sense. If I make some tea, I might stop eating cinnamon cashews. So what I'm thinking is duplicating that code on the laptop is a win-win either way, because if it causes the problem, then we isolate the problem. If it doesn't cause the problem, then I can check it in over there, and that's factored out of the changes from this build, that then if we have to revert or like diff analyze or something, we have less to think about. So that's good. Okay. I'm going to open up the laptop here. And over here, I'm going to go to those return changes. You know what? Let's do one last thing here, which is a full rebuild. It's probably not the problem, but I've been bitten so many times by Visual Studio not building things correctly. Okay. Yeah, let me take this out. Wait, where was it? There. Take that out, and it'll fail faster again, right? Yeah. So, very weird. Now, if I go here to here, all right. Let me just double check while I'm looking here as well. We're not really doing any work in here twice. We're just calling check that types match on each argument. Do we do work up here? Nope. Not really. I mean, these error checks aren't going to do anything really bad. So let's just, I'm going to duplicate the, oh, okay. First of all, we got to update to the current compiler and make sure it passes all the tests and things. Okay. I'm running the tests. This is just still with no modifications. This is stock from source control. And it looks fine, but we'll let that run for a second. Meanwhile, I can go to the code that we are looking at here on this other laptop. I can add, so there's two things, right? There's a header file where we added this type check argument cursor. All right. Really takes a while to run the debug tests on the laptop. Oolong doesn't necessarily seem like it would have that much caffeine because it's not that dark of a tea. Like, obviously you think if you're drinking like, you know, English breakfast or something, you're like, oh, okay. But like oolong doesn't seem that intense, you know? Black teas do not have the most caffeine. Green teas do. I think that's false. I think you got that backwards. Google says black tea 47 milligrams, green tea 28 milligrams. I need to get some caffeine-free teas in the home here, though, because I drink tea for the flavor, not necessarily for the caffeine. Oh, right. If you're thinking like green tea with matcha, that could easily, by the time you throw the matcha in, that could easily have more caffeine than black tea. That's sort of the exception. No, green tea always has caffeine. I mean, unless it's decaffeinated. It definitely has caffeine. It's just a little less on average than black tea, like half. A lot of the herbal teas taste terrible. That is true. That is very, very true. Okay. So I am going to now duplicate these changes here, which are pretty easy. down at the while loop now. So increment at the bottom. We do the yield maybe, we do the match check. We gotta give our I. Okay. Pretty simple changes. Let us see what happens. Oh, I messed them up. Have another shift key problem. Okay. Now I'm building the tests with those return changes. Looks like it's working. We'll let it go all the way through. But okay, so that's good though, because that factors that out of the problem that I need to think about here, about what's wrong. Which, you know, easier said than done sometimes. Just letting that play out. VR would not break most of the puzzle mechanics. That is false. I don't know why people think that. They would work fine. There is one puzzle type that wouldn't work very well in the entire game. One. Out of all the puzzles in the game, there is one. Okay. Well, those tests passed. So I'm going to check this in. Oh, hold on. Hold my horses. I have to make sure the game compiles. Just in case that has something. Branches in the temple, false. Those would work fine. It's almost like you guys have no idea and are just guessing. All right. Commit. Okay. Cool. Cool, cool. So that, however, doesn't narrow things down. So I really don't have a theory here. It seems like a very consistent bug. I kind of want a more minimal repro. Let's look at, okay, so when I went back here and put that in, we got another fail later on. And if I look at the later fail, that might be a simpler scenario, maybe. Oh, that is not simpler. At all. Okay, I bet inputs.count is wrong, right? Is it here? That's not what's failing. Which one? See, we can't necessarily tell. Oh, it's probably this one. Dang it. Like, I don't know why we're doing that all as one thing, but okay. Sure, it's taking it a while. Okay. It's probably the very first thing. Let's just do like no, that was fine. That was fine. I don't know what to say then. Like, we can't make VR games because nobody buys VR games. It's just not a thing right now. There was a brief window when you kind of could. We asked Valve if they would fund our VR game. They said, fuck off. So I was like, all right. Gabe didn't say it. It's, what's his name? What's his name told us to fuck off. He didn't say it in those exact words, but... And that's the thing is, like, almost nobody making VR games actually understands how to design for VR. And so they're not showing people why VR is good for games because they're not designing games that are good for VR. Even Valve is not really doing that. I mean, they're kind of doing it a little. And so, like, I'm not that surprised that these headsets didn't succeed in the market yet. I think they still probably wouldn't quite have, but they would have done better if the games were better. I guess I've said this before, but there's been a huge design failure in the VR area. You're hearing a lot of developers are doing really well with Quest right now. Define doing well. How many dollars a year is doing well? You're making literally tens of dollars. Literally tens of dollars. You make enough for what team size? $30? Oh, that's pretty good. Like, if enough means enough to pay for a team of 30 people, that's pretty good. I mean, I think better hardware would help a lot. It's already gotten better since the first ones, but better will help a lot. But you also need to show up with design. One of the plays in VR is hoping Facebook buys you. Yeah, that's not the path I want to be on. Not the path I want to be on. Okay. I didn't go to them with a specific idea. I just asked about, so Gabe had said some stuff about funding VR games. So I asked about that and got told in no uncertain terms that they thought I was a loser. So, do I think there's a missed mechanical opportunity designers are missing? Yes. Do I think VR movement is solved? Not really, but I think people are mostly in the wrong place with it. Didn't they tell me that with Braid as well? Yes, they did. Braid got rejected from Steam, and then they had to come ask me later after it was a hit on Xbox Live. So, what do I mean by wrong place? I mean all this weird like climbing up walls shit and whatever that they're putting in VR games. Like 2018 was the year everybody put climbing up walls into their fucking VR games, and it was horrible. Like the Valve finger controller thing was so bad that you can't really use it for anything, but people tried to use it. Just stuff like that. So I'm not quite sure what to do next in this debugging because I don't have, I kind of want to take a break, but also Chads get things done, right? So I don't know what to say about any of this. Everybody said, no, I didn't miss wiggling your fingers to calibrate it. I did that 37 times, dude. Everybody says, oh no, you have to wiggle your fingers to calibrate. I did that so many times. It just doesn't work. It just doesn't work. Not decently well. It doesn't work at all. Don't tell me that it works. It fucking sucks. Like, that's what I hate. Like, the PR thing, like, this wiggle your fingers thing is an example of a weird PR tactic that has happened in the world. And it's part of the reason why things don't get fixed. Like, I'm sure there's a few Valve engineers that think that wiggling your fingers will make it work, but they know it doesn't work, okay? But people can like convince themselves that it kind of got better after they wiggled their fingers some, right? And maybe it does by like 10% or something. And so because people are so suggestible, they'll be like, yeah, this is totally working better. And anytime somebody has a countervailing view, like, no, this totally doesn't work. The rest of this controller is great, but the fingers like don't track. In that zero knowledge internet way, people just say, oh, you just have to wiggle your fingers. You're not doing it right, right? And it's like saying as the developer, the way that you calibrate this device is by wiggling your fingers gives people a Dunning-Kruger internet excuse to shout down the people who actually have a clearer eye for what's happening and what's working well and what isn't working well. And that fucking pisses me off so much. I've heard so many times you have to wiggle your fingers, you're not doing it right, from people who didn't even look at the part of the video where I was doing that. Like, we tried it in the Valve Hand demo. We tried it in Alex. We tried it in several other games. It doesn't work. So what wiggling your fingers is it's some kind of like brain meme self-defense against product defects. It's like a way to get your stands to defend your product even though it has obvious problems. It's really weird. Like, so many people have said that. Okay. Now that I've ranted about Valve for a year, I am not sure how to repro this problem right now. So maybe I'll go back to the earlier one. Because I just want to know. Let's kill these buffers. Whoops. That's where I meant to be. So we're going to go back to here and get the early fail. Whoops. The early fail. Pretty strange how it is invalid thread index. So I could at least break there and see what the data structures are like, right? All right. So arguments. Like, what is this UI here? Okay. Assertion failed. Add work. Okay, so we knew this. We knew thread index was wrong. Why is it wrong? Group. Is next worker index using what? Oh, no, there it is. 0. That means thread index was wrong before we even got here. That means the parameter was 32758. Right. There we go. Okay. This whole thing is messed up. After errors, after that array element, the whole struct is messed up. So something about the way that I did the type checking inside the struct literal caused it to stop at the array literal and never resume, which is weird. It might be explicitly checking for a cast. I don't know. But then everything after this. Okay, we should be able to reproduce this in a scenario. We could say thing is a struct with x is 5, y is 7.0, array. Oh, we need, okay. So we have a holder dot 1 to okay. And then z is 1, w is 2, k is 3. We're just going to see those get messed up. All right, holder is a struct with a int, b, int, c, array of int. D is a string, E is a float, right? Okay, much more minimal repro if this actually repros. Well, it dies printing the value, so that's pretty good. What? Yes, please. All right. There we go. No! It's like it's a little bit laggy and I clicked and then it changed or something. It's like, come on, guys. All right, excellent. So what is T? The data pointer of the array itself is messed up. Pretty weird. So then if I make this int dot, does that work? I think it does, right? Yes. Okay. My laptop fan, even though I'm doing nothing with the laptop. You know, though, so Choco Taco had a sponsored stream today, and he had some MSI laptops that he was giving away. And the one particular one he was giving away didn't look that good to me. But they have some other ones that might not be bad, so I might switch. We'll see. It might be a thing that could happen. Would I bet on starting a computer graphics career in VR or mobile? No, neither. Neither. Do PC, yeah, do PC consoles for now. You can always go to VR later if you want. It's the same stuff. Like the math and the tech and all that you need, you get from PC consoles, and you could actually get jobs in PC and consoles, and or you can still make an independent project on PC, launch it on Steam, and do very well, right? Okay, so back to this. What is happening here? The mystery to me is that these are all correct. And this is even correct. Okay, so I'm going to comment out this stuff for now. Right? And we're just going to see what happens when we do the copy struct literal into global data. Okay. Line 336, that's not the right one. The one we want is going to be on line 14. There we go, maybe. Okay. So we go all the, I should have made it shorter. Anyway, we're copying the struct literal. So the index on this one is 0, 1, 2. So we want to go, so 0, 1, 2. This is the array literal, probably. Element type. I mean, it looks right offhand. Yeah, it's 64-bit integer. Info. Statements in order 3. Input expressions 3. These all look fine. Okay, wait. 24 bytes. Base address 184. Size 24. It's all correct. This count is not even used. Oh no, it's used there. I mean, this has turned into kind of a slog, honestly. Because I don't, so now I'm having one of these, like, I don't understand what's going on here. Oh, wait, no. This is the wrong type. So we're, okay, 24 bytes is correct for the size of this array literal, right? But, oh, Okay, so what's going on is there's a missing cast here. There's a missing cast. Remember when I said, hey, we don't need a cast? It's not really true. That's the part that broke it. I understand now. We need a cast if... All right. All right. I get it. The Feynman method came in late, but at least I know what the bug is without having had to like slog down to the very end. So, I had this thing called Kali. I guess we deleted that variable. Hardened literal. Remember this part that we did? I do. This thing where we say we harden a literal and do all this. So down here, we said, don't make a cast right here. Okay. The reason I was doing that is because we maybe don't need it. It's a literal. Oh, we always need a cast for wanted. Oh, okay. Dang it. Okay. We're going to explain this. All right. Unhandled expression 26. That's a totally... What? Oh, because it doesn't... Doesn't like something. It's 26. Cast. I think this specific thing... no, because it worked here. Like what? Why does that work? We're getting there, but we're not totally done. Okay. So when we get here, it's a shallow cast on array literal. This is what we're trying to trigger, right? Oh, but... all right. Anyway... We can go here again. What? Hold on. All right. So this is where we want to loop through. So we can go back here and disable this. And when it's line 14, we're going to step in here and see what's wrong in this other version, because I feel like the cast should be correct, but maybe it ain't. Maybe it ain't. 33614 0 1 2. Okay. it's a cast. Okay. Where was the shallow cast on array literal part? Down here? It's a literal. Oh, it's the and part that fails. What? Oh my God. Got to trace through all that again because Visual Studio sucks. Source type. Is what? No. Come on. Literal. That's what I expect. But it's inferred type. What is the literal being set to? Oh, is this interp type def unary literal? I see. I see. You know what we didn't ever do? And by that I mean me. I didn't do an obvious thing. All right. Wait. Neither of these should have fired. Okay. 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 We need to get back our breakpoint in the hardened. Oh my God, so many breakpoints. Somewhere. We need to get that one back. Oh, it's in matching. Okay, so let's go back to here. Ignore that. Here we go. Now, this literal WTF so I assume that its info is going to have this member waiting for type binding set to true. It shouldn't. So But I bet it will, but I'm not sure how that will have happened. So first let's verify that that is maybe happening. WTF. Really? Oh, because are we accidentally copying the type? Hold on. We're not supposed to be copying the inferred type. Did I have that wrong? Like what? Okay. I think I put the info number in here and not the literal. All right. Info not waiting for type binding. We're doing the type check. This is what's supposed to happen, so this is fine. We run down here. We make an array element type, which is this. We set the inferred type. That's all fine. Zero, 1, 2, 3. Wait, what? Did I take my breakpoint out of copy array literal? Yes. Dang it. All right. So we get the harden this literal. Oh, wait. No, okay. So that's the same number. This is fine. 620. We infer types for 620. It does the right thing. We get here. I bet we're just looking at the old one. I bet that's what we didn't do the right thing with the switchable expression, probably. Similar to what happened with return, but different. So 0, 1, 2. Oh, I freaking what? Is going on? Oh, because we don't go down into it. That's right. We don't copy it. That's the problem. Hold on. There, 2. It's a cast. We're casting 2. Okay, that's good. I mean, I'm not going to thoroughly check that, but it seems fine. Okay. Source type does not have an array element type, right? Source type came from cast expression, which is this literal, right? That's the old one. 546 is the old one. Okay, so now we go back here where we do the harden. Why is it the old one? We come back. Okay, given expression has changed. Oh, wait. Did we cast the wrong thing? Sorry, star. Literal. Okay. Array literal. 546. We somehow returned the old. Oh, God. Guys, how is Babby formed? I know what I did. I know what I did. Guys, I didn't look at the code. I copied this line from down here up here without remembering that, God damn it, it's a different value. And thus I had to debug for like a long time. I hope somebody was yelling that in chat and I didn't look at chat. This is why the Feynman method is sometimes superior. If I had done that instead of debugging, I might have done much better. I'm a little disturbed by this other thing. Oh, no, there we go. We are running debug, so sometimes it takes a while. Gosh, I'm getting so much email. So much email. I'm just deleting it. I'm pressing the delete buttons. Boom. Delete. Delete. Steam Deck dev kit requests now open. Delete, delete, delete. The problem is it doesn't cost anyone anything to send you an email. If it even cost like 5 cents, you wouldn't get all the spams, right? Have I checked my mailbox outside? I hardly get any junk mail anymore in my physical mailbox because I think they've given up on it. Because it doesn't work and it's so much cheaper to send emails. Do I ever delete beta request emails? No, but I do throw them into a folder that I don't really look at. Yeah, you know what? We should get a Steam Deck request here. Let me figure out how to do this. I'll go into high security mode here for a second. Dear Gabe, how do I request a Steam Deck? Oh, did I delete those already? Gmail is suggesting Stream Deck. I must have just deleted them. Steam Deck dev kit requests. Now open. Hardware request form. Development and testing of Steam Deck for these games. Okay. I should update my shipping address with Valve. Because, like, mailing addresses. Manage addresses. Oh my gosh, there's so many addresses and they're all old. Oh, wait, that's okay, that's Gmail. Okay. Right, the browser. Wait, what? Okay. Okay. I have now given Valve my addresses also. We'll see. I mean, they told me to fuck off when it came to making VR games. Okay. Also, you get it here. No, that's just the announcement. You have to click on this thing. This is the announcement, but you click on this link and you go to your Steam developer login. Steam Deck isn't sold out. Yeah, but the developer kit might be different, right? So, for example, dev kits for consoles often have more RAM than the actual console has. Can use a dev kit to play regular games. I don't know. On consoles, the answer to that probably varies, but it's usually no. But for Steam Deck, I have no idea. I mean, Valve isn't into locking people down, so I would guess maybe that you could, but I don't know. Why is there more RAM on the dev kit? Yeah, when you run your debug build, it takes more memory. When you're in development, your game isn't as optimized as the final build. Like, you need the hardware to be able to run something less good than the final game in order to get to the final game, right? Okay, some of these are infinite looping still. I don't like that. But we got through a lot of them. I didn't think this was going to be such a big change, although I didn't think I was going to be working on this today. These are all polymorphism stuff, which I don't like. Okay, let's do this one. This one's probably pretty simple. So this is gonna infinite loop. Let's get rid of all these frickin' breakpoints, dude. Just the line must be drawn here. We'll just let it go for a while, and then we'll say break. Just want to make sure that we don't get it too early. Okay. Debug break all. Need size to build. Whoa. What? Really? Oh, because I bet we're re-flattening all the time and we just end up here. Okay, let's just see. I bet we're ending up here, right? Yeah. We just keep going here. So it's another one of these things where our output is different than it used to be before, and not everybody is handling that correctly. Oh, this is an array literal problem, which is different from the struct literal problem. So it's an array literal inside an array literal, probably, maybe? Yes. So type check cursor is 0. Let's just take a look where we are. Line 137. Array literals. Yeah, it's an array literal full of array literals, and the outer one even has the type designated. Okay. Oh. Yeah, we're not handling... No, okay, hold on. Hold on. Hardened literal. Boom. Wait, what? We push and flatten the hardened literal. That's fine. It's a fixed array. So we're not actually setting the switchable expression. This used to actually be correct. Okay. This is what we need to do here. I think. Yay! See, that was less of a slog because we're learning. We're learning how to program. Do I have an idea for what you should make with GPT-3 beta access? Teaching people how to get good. Any good compiler books? No. "25 IQ. I'm afraid that's not possible. 24 is the highest IQ. 24 is the highest IQ. Forget about it. I don't feel good about how many are remaining right here, but maybe they'll finish. I didn't have a bad feeling about this. Oh! All right, well, we got a couple now. And they're polymorphism ones, which means we may be in for a world of pain. We may be in for a world of pain. Did you just fail on the last test? No, not on the last test. What happens is we buffer up the fail reports and just print them at the end. I mean, let's do this one. Okay, so we're going to run that. We're going to let that go for a while. And it's going to be a variant of the same problem that we've been seeing a few times. Yeah, the test running program says no program should take, whoops. should take 30 seconds. I didn't have that running. I thought I was waiting for it to run. This is probably enough. Boom. Okay, so why is this happening? We harden the literal. Okay, so we didn't match. Oh, this seems bad. Yeah, and this is okay, so hardened literal goes in there. And that's in the polymorph loop. Where did value come from? Okay, so clearly if we yield, we're hosed here. This was never correct. Because this is a local variable. See, sometimes handling yields is kind of error prone. Wait, what? Baked value. Oh, I left off the S. Sometimes it's error prone and it's just more of a hassle and it just ups the complexity of code generally no matter what, which is why, of course, we would like to do it yet less. Oops, I didn't type the compiler. Oh, yes, I did. Still not working. Still not working. All right, let's just try it on this one. This one might actually complete because I just ran a different one. Yeah, interesting. So the one that I just supposedly fixed is this one. Whoops. Oh, but it's erroring. Oh, no. It should be string. Okay. We have so many problems today. It's actually an array literal. Not a struct literal, bro. Or array. Let's run it back. Okay. What happened there? What happened is, once again, we didn't frickin' handle the thing right. So we go back to the harden. How many times do we get here? 1, 1. That makes it easy. 1, up, go, go. We push and flatten that. So hardened literal is, of course, non-null. So we set the switchable expression. We yield. Okay. So now we're back in the same place next time. So I need to see WTF is going on. This is probably unary literal. Whoops. No, interesting. Okay. So this is actually correctly set to array of strings. So maybe maybe we don't F up here, but maybe we do. Why is it so hard to select? So matching true, yield upon didn't get set. Okay, so we actually finished this. So we finished this. Here. So we must be like infinite loop spinning on the polymorphs now. For some reason. Like what? Wait, what? 11. Why would we do that? So we make a struct. three constants. A, B, and T are going to be the things. And what I want to know is, oh, I don't really need to know anything. What I'm not sure is why we keep polymorphing. What is happening there? I mean, well, maybe I should look at this while we've got it. I don't know. I don't know. Okay. So what have we got here? We have got clearly it's infinite looping, and it looks to me like it's infinite looping by regenerating the same polymorph every time. I honestly don't know how that is happening. So what I was going to do was go set a breakpoint in like the struct polymorph function, which I guess I don't remember exactly what it was called. But it's got to have something to do with the result not being particularly satisfactory. Because why else? Like, I'm projecting forward in my head and I'm thinking, well, I'm not really, like, even if I set a breakpoint there, that's not necessarily going to give me information about how we got there. Although how could it not? How could it not? It's just sometimes you're in one of these places where it's like, well, I need, this whole debugging game is like, how do I get the information that I need to understand the problem? And, oh, wait. And no, guys, I'm dumb. We're not infinite looping, right? This is what happens when I've been working on too many things. We're not infinite looping. We just get this error. That's the thing. I'm a dummy. So at this point, actually, it should already be wrong. If I look here at in the constants block at the members for I guess the expression bound to be, right? This is T, this is A, this is B. The expression is a literal, and this is going to be the wrong literal again, because in the old days we modified it in place and now we don't, right? So array literal values, array literal info, no element type expression. So how did that happen? Okay, now, so we're back at the harden. We do the harden. We put it in baked value prior to modify directives. Okay. This is going to be a yield upon, right? We're going to yield at index 0, prop 6510. I'm going to F5. We're back here, index 0, prop 6510. We're going to call check that types match again. And I mean, in theory, this should be, oh, okay. Okay. The problem is this thing down here was designed to notice if this put a different thing in. Okay. But this time it's not going to put a different thing in, right? So if I say value and I say old value, it's not going to put a different thing in. Okay, so we actually need to do this first before yielding, which this is why I hate the yielding, man. All right, so So I got to do this. Okay, because we could return false for matching, but it doesn't mean anything because we're yielding. So, all right. Gonna do this, gonna do that. Okay. Sometimes the fixes are so easy. But they take forever, you know? Okay, what was this one? Okay, this one's still infinite looping now. God, why? I didn't know this was going to be so painful. Like, we still have to do all this with struct literals, but hopefully it'll go faster. Oh, wait. Oh, no. Okay, yeah. All right. I'm still going. I never got the nap. This turned into a giant slog to fix something that I didn't even think was going to be a problem when I woke up this morning. But I guess I'm happier doing this now, discovering this for myself, than I would have been if somebody emailed me an email and said, what the hell? Overloads with arrays don't even fucking work. What kind of programming language is this? I would have been like, what? But I noticed it myself, and now I'm like, oh, yeah, I get it. All right, so hard and literal. Let's just let it go for a while because we don't know what's causing the loop, so we're going to let it run. All right. Solve for matches non-looping. Okay. So the pointer is the address of, oh, see, this is again fucked. Like, okay, that's obviously wrong. Okay. Is this going to matter? Because yeah, I would like to get the yielding out of here, honestly. So the thing is, we don't really want to use expr here. Let's just type it out because I don't want, that could also be toxic waste that creates a mistake having that variable lay around. Oh, because this is still running. Oops. Stop. Thank you. Still, really? Hold on. I don't trust what just happened. Let's build the thing. Okay. All right. Well, it still doesn't work. Dang it. Giving it some time. Here we go. Check the types match. Harden literal. So going up, going Probably the same problem. Yeah, this is a local. What am I doing? This is like sometimes code just breaks over time. Oh, no, we do yield later. Oh, I bet we return false for matching though because of the yield. Or maybe we return true. I don't. Hold on. Let's see. No, matching is true. Expert, old expert. C90, yes. Okay. Yield upon. See, we didn't actually poke it. Like what? I can't believe this is kind of interesting because we found a lot of yielding problems that could theoretically affect other stuff. But my plan is to get rid of all this yielding anyway. So in the end, it doesn't even matter. My neck kind of hurts, so I might want to take a neck break. We're going to run a Benny test on all of Sokoban too, just to make sure. Hey, look, we passed, unlike college. That was painful. But it gave us something. Gave us something. All right, so we're going to make a release build in Benny test. All right. And then I'm going to get a reward for having done all this. Okay? I tell you. Are you ready? While we run the Benny test, are there any questions about what we've been, serious questions? Because that was a slog that I'm sure was hard to understand for many people, but you've got to do that sometimes. Sometimes you have to do that many times in order to get to a reasonable place. We still have a bunch of slogging to do, but hopefully it'll be a little bit better than that. So any questions about this? No, I never want this message. Peppermint Crunch. I have some peppermint stuff, but I already had some of those. Questions. was the problem and how did I fix it? Look, if you weren't watching the stream, that's not my fault. The problem is yielding is a little bit complicated, but that's the price that we pay for having a very advanced compiler. You know, basically nobody ever understands what we do on this stream. I don't know why we stream, but it's okay. I think I was kind of hunching due to how unpleasant that debugging experience was. You know? Just like Did I fix everything? I mean, all those bullet points I was doing at the start, no. I fixed the problem that we discovered, or that I suspected and verified, that array literals didn't work with overloading correctly. We should make some regression tests for that, by the way, before I end it. Maybe tonight we'll do some level design after a break. That would be fun.
Telling the truth can be bad news.
Telling the truth can be bad news. Telling the truth can be telling the truth can be good news.
Telling the truth is a bad idea.
Telling the truth is a difficult problem.
Telling the truth is a scary. Telling the truth is a scary predicament.
Telling the truth is a
Bitter herb.
Telling the truth is a dangerous tunnel.
When you get out of that tunnel, you've got
it's
bitter
a black
herb.
life ahead. Forget herb. I never heard of a hit that had the word herb in it.
Telling the truth is a dangerous
Dangerous.
Telling the truth can be dangerous.
What? Danger. Telling the truth can be dangerous. Telling the truth can be dangerous
business.
Telling the truth can be dangerous business. Why? Why?
Why?
Telling the truth can be dangerous business because if yourself,
Because
you
if
don't
you
know why.
Huh?
Well, I'm just giving you what the idea is. Telling the truth can be dangerous business. If you don't know yourself, then you don't know why.
Oh, is that brilliant?
Telling the truth can be dangerous business.
Honest and popular don't go hand in hand. If you admit that you can play the accordion, no one will hire you in a rock and roll band.
But we can't sing.
Can sing our hearts out, and if we're lucky, we'll no neighbors complain.
All right. So that was one of the no check-ins. Uh-oh. Not all control paths return a value. Okay. This is good. We got two more no check-ins. You know what? We're not going to do this one right now. We're just going to put it on the to-do list, though. Because it's not that important. After a big slog like this, we're not going to risk it by changing something like that. And this will explain. Okay. If we are here, we know array type not equal to array fixed, but because we are casting from a literal, the source type is array fixed. Thus, we need a cast because this is not just about converting the element type. It is about e.g. casting from n to whatever. Okay, baby. Now I'm going to have to update, and I hope we don't get a merge conflict with the thing that I checked in off the laptop. We probably will. Sometimes it sort of notices that it's exactly the same. Nope. All right. So, although ask.h merged, what happened here? What was the variable called? Silent check matching failed. Okay, see here it said, oh, you inserted the same line twice. So we're just going to merge that. But in Typer, it didn't exactly work out. So, all right. I mean, it's the same, guys. All right, that was the only conflict. Let's make sure it runs again. Alrighty. Why didn't I check stuff from laptop before? Because I was in the middle of other things. It was already broken. It wasn't good. Yeah, it's not like I could test that I merged it correctly because the game was already broken. All right. This is good. This is good. Did I put a changelog? I think I did. All right. That was a painful 6 hours. I still have, in tests. Yes. Let us simply revert this. We didn't want to change that. All right. Here's what we're going to do. I'm going to take a break. Then I'm very likely to start a stream in an hour or so. Maybe a little more. Where we work on the game instead of the compiler. And we'll start by doing a little bit of programming on the game. But then after that, we could do some level design, hopefully. So that is the plan. And we're going to have a chartreuse latte because I haven't made one of those in a long time and I deserve one after that. So there we go. Thanks everybody for coming by, and we'll start up again in a bit after a break. It'll be good. See you later.